Yeah.
So you mentioned sampling and equations. What are there any specific equations? I know you said it's like stats. I just
Yeah,
want to
so some of the standard equations are the standard deviation, right, of
okay, cool.
a normal distribution. You're familiar
All
with
right.
that one.
Yeah, yeah.
They call it a Gaussian distribution, or the bell curve, or the standard
Okay, cool.
distribution, or something like that.
Yeah.
And what you can do is, you can't do a standard deviation on one point, and you can't do it on. You can try it on 2 points, but you don't get very good representation. But if you think you've got but basically, the rule is, if you take the square root of the number of the population and that's your sample, you'll get a good representation. So if you've got 1,000 people, if you sample the square root of 1,000, which is something like 24 or something like that,
Yeah.
you might get a good representation of the population. Yeah. So with sampling, you start to understand how many things you have to look at before you get a good idea about the population, right? And so there's a transferable that's analogous to what we should infer from the behavior of one person.
Yeah.
Right. You can't. There's some saying, right? You can't paint everybody with the same brush, right?
Gosh, yeah.
Yeah. But governments need to understand that they can't just look at what one person did, right, and use that as an example to put laws on everybody. Yeah.
Yeah.
And the other way around, I guess. But
Of course, yeah. It's
a sensitive topic over here right now. In fact, yeah, I'm not in a.
interestingly enough, just touching on that point. I mean, I'm jumping a bit to what I would normally talk about at the end of this first session, but I have some ideas linked to our observation as human beings, and I put it to David Kaplan that our perception, it seems, might limit our scope of realizing, I guess, what you could call real reality, right? So maybe unless we evolve our perception, we are actually confined to only a certain limitation of knowledge.
Well, so have a think back about the leaps in understanding that we've had from the genius of human beings, right? And so I think that's a good measure of genius, is when you think it's thinking outside the box, essentially.
Yeah, exactly. Yeah.
And so if you've had it drummed into you, right? So let's go back to the 15th, 16th century, right? You've had it drummed into you that Earth is perfect. It's the only place there's
That
no
is
other
flat.
places. Yeah, and that the stars are just the holes to heaven, right? If you then start picking away at that and you start to see, well, the planets aren't perfect, right? Because they've got a little bit of wiggle in what they do. They're not following perfect things. And then you go, oh, maybe what I've been told isn't, well, that observation that I've made doesn't fit with what I've been told. So how can I explain that observation? But if you've been conditioned and you are firmly dogmatic in what it is you've been told, you're not going to learn anything. You're not going to, you have to step outside of your comfort zone.
Yeah.
And you have to realize, well, maybe the heavens aren't perfect, right? And so that's why I think Kepler was a genius, right? Is because he was being told over and over and over again, the planets are part of the heavens and the heavens are perfect. Therefore, the planets have to be on perfect circular orbits. And his mark of genius was to say, why? Why do they have to be perfect circles? If I just say they can be slightly squishy elliptical orbits, I can explain all of these observations.
Yeah.